Hello everyone, in this video I'm going to be discussing the difference between heat, temperature, and thermal energy. And I will also go into some detail about the differences in the ways that heat can be transferred. So let's begin with temperature. Temperature is a measure of the average kinetic energy of the particles in objects. So what this tells us is that all moving objects have kinetic energy. Matter happens to be made up of tiny particles that are always moving. So these particles have kinetic energy. Further, that as an object heats up, its particles are going to begin moving faster, so its average kinetic energy will begin to increase. All right. You can also think of temperature as how hot or cold something is compared to a reference point, but the specific definition we want to think about throughout this presentation is that it is the average kinetic energy of the particles in an object. Next, we're going to discuss what the units of measurements are that we use for temperature here in the United States as well as around the world. So here in the United States, we measure temperature using Fahrenheit. That's what you typically hear when you turn on the news. Celsius is the unit of measurement used in countries around the world, and Kelvin is typically used by scientists. Here, for the purposes of this class, we will be measuring temperature in degrees Celsius. What is thermal energy? Thermal energy differs from temperature in that it is the total energy of all the particles in an object. It tells us that the more particles an object has at a given temperature, the more thermal energy it is going to have. This also means that the higher the temperature of the object, the more thermal energy it has, even if it has the same amount of particles as another object. That's the example that we see here down below, where we see the 4 different pies, one at 100 degrees Celsius, one at 200 degrees Celsius, one at 200 degrees Celsius partially eaten, one at 200 degrees Celsius completely intact. All right, so on the figure on the left, as we're comparing the 100 and the 200 degrees Celsius, they are both intact pies, but the 200 degrees Celsius one is the one that has more thermal energy because it has more particles, and then with the right side, the 200 degrees Celsius that is intact has more thermal energy. Heat is the transfer of thermal energy from a warmer object to a cooler object. Heat is going to stop transferring when the warmer object and the cooler object reach the same temperature, which is known as thermal equilibrium, and that's what you see here in this picture below, that as they come into contact, they slowly reach the same temperature of 50 degrees Celsius, which is halfway between 0 and 100. Heat can be transferred in 3 different ways, either by conduction, convection, or radiation. And again, heat is always going to be transferred from the warmer area to the cooler area by one of these 3 methods. Convection. It is a type of heat transfer that occurs only in fluids, such as water or air. The heated particles rise and spread out. The cooled particles fall and condense. That's what you're seeing here in this animation. The heat is rising, the cold is falling, creating something called convection currents. We actually experienced this phenomenon in our school building in September, October, when it was still very warm. You guys might remember that going into the 3rd floor was significantly warmer, hotter compared to the 1st floor or even the 2nd floor. Reason being, again, due to convection, the heat is rising, making the upper floors a lot warmer than the lower floors in a building. Radiation is the transfer of energy by electromagnetic waves. It does not require matter. So that means if you're sitting around a fire, you're going to feel the heat radiating off the fire without having to touch the fire to get warm. Same idea as if right now you're sitting right by the heater, you're feeling the heat coming off of the heater without actually having to touch the heater. And then finally, conduction. This is the transfer of heat from one particle to another within an object or between 2 objects. Another way to think of it is that this requires direct contact. So just kind of imagine the metal rod stuck in the fire for a very long time. The metal rod becomes heated, and when you touch it, the heat is conducted from the metal rod to your hand via that direct contact. In just a few seconds, I'm going to show you and explain just why it is that the metal rod conducts heat so much better, and that's because metals happen to be good conductors of heat, whereas things like air and wool are better used as insulators of heat to keep the heat in. Further, some materials are going to expand or contract as they heat or cool, so most matter is going to expand when heating, contract with cool, except for water.